Approximating irrational square roots. Although irrational numbers never repeat, we can locate them on the number line with any needed degree of accuracy. We do that by finding two rational numbers with the needed accuracy and place the irrational number between them. If those rational numbers are accurate to tenths, that's the accuracy of our placement. And if needed, this can be done to any accuracy, not just to the tenths, but it could be to the hundreds, to the thousands, whatever is necessary for the problem. We will practice how to do that with irrational square roots, the square roots of numbers which are not perfect squares. Approximating the values of these numbers dates back thousands of years to the ancient Babylonians. Many techniques have been developed since then, including by Isaac Newton. Modern versions of these techniques are what your calculator uses to generate roots of numbers, which is why we know that irrational numbers never repeat their decimal pattern. Those approaches are very specialized. Our approach will be to apply general principles, which is fine, to the accuracy we need. So let's consider as an example the square root of 8. So if we have our chart of perfect squares and what their square root would be, think about where would the square root of 8 fall? Well, the number 8, or the radicand, the number underneath the square root, 8, is between the perfect squares of 4 and 9, but it's closer to 9. So the square root of 8 is between 2 and 3, but closer to 3, since the square root of 4 is 2 and the square root of 9 is 3. If we just needed accuracy to the nearest integer, our answer would be 3. But what if we need accuracy now to the nearest tenth? So to do that, we'll draw the number line between the two integers we identified. We identified 2 and 3 because that was the square root of 4 and the square root of 9, and we said, remember, the square root of 8 is going to be somewhere in between them, but probably closer to the square root of 9 of 3. So then we want to show those integers of 2 and 3, and also as the square roots of those perfect squares, and then label all of your numbers in between 2 and 3 to the nearest tenth. So 2.1, 2.2, 2.3, 2.4, and so on and so forth, all the way to 3. Since our number will always be first approximated as being between two integers, the number line will always look like the one below, just with different integers. Again, we're using 2 and 3, but it can be any two integers depending on where the square root of your number is located between. Now let's guess where the square root of 8 would be located between the square root of 4 and the square root of 9. Since 8 is closer to 9 than 4, let's try around 2.8. and see which we need to check next, 2.7 or 2.9. It just takes a minute to square 2.8 and get that 2.8 times 2.8 is 7.84. This is a little less than 8, so now let's square 2.9 to see if our answer is between those numbers and see if so which is closer. So 2.9 times 2.9 is now 8.41. So since 8 is closer to 7.84 than 8.41, our answer is 2.8. So the square root of 8 is equal to 2.8 to the nearest tenth, because again, when we square 2.8, that is the closest number we get to 8 itself. If we needed to find the answer to the nearest hundredth, we would repeat the process with the numbers between 2.8 and 2.9 as shown below. Right, so now our number line is surrounded 2.8 and 2.9 with numbers in between to the nearest hundredth. And maybe again we'd start by guessing 2.82, so we'd square 2.82 and see what number that is how close is it to 8. Maybe we had to square 2.83, and we could repeat this again using computers millions of times to find a number to any accuracy. But we won't estimate beyond the nearest tenth in this course, so don't worry about that. If our guess had been way off, for instance, if we had guessed, let's say 2.5, we'd see that we needed to test higher numbers, so maybe go straight to 2.7 or 2.8 after that. No matter how you guess, you shouldn't have to square more than a few two-digit numbers, which doesn't take that long. And again, we then get a good approximation of the square root of 8 without using a calculator. So here's another example. Let's do the same process, but now let's do it for the square root of 30. Let's find the value of this number to the nearest tenth. So the first thing we should do is look at the radicand, or the number underneath 30, and see which two perfect squares it falls between. You should see it falls between the perfect square of 25 and 36. So it's about midway between those two numbers, 25 and 26. So if we create our number line with the square root of 25 being 5 and the square root of square root of 36 being 6, about halfway is 5.5. So if we square 5.5, we get 30.25, and that's a little bit above 30. So now let's square 5.4. Let's try 1 over, and that's 29.16. So our answer is between 5.4 and 5.5, but it's closer to 5.5, so that'll be our answer. The square root of 30 equals 5.5 to the nearest tenth.